Now, if I flip this over, on the back of the lab, oops, wrong page. On the back of the lab, you have to do all of these things. We created the horizontal scale, we created the vertical scale, we drew the line for high tide and labeled it, we drew the line for low tide and labeled it. It says place an N on your graph to represent where the Neap tides occur. So, the two tides, the two special tides that are causing this change in tidal range are called Neap tides and spring tides. All right. When I'm going to use a little spot that we have on the back of our data table to compare and contrast Neap tides and spring tides. So this doesn't have to be on your lab, but over here I'm going to write Neap tide, and here I'm going to write spring tide. Okay, Neap tides occur twice every lunar cycle. For the Neap tides, you're going to have the Earth, the Moon, and the Sun at a 90-degree angle. All right. When you compare that to spring tides, on a spring tide, you have the Earth, the Moon, and the Sun are aligned. Okay, they're all lined up in the same direction. The phases that you're going to see for a Neap tide, the phases that you get when the Earth, the Moon, and the Sun are at 90 degrees, that's either going to be your first quarter or the third quarter. Okay. For spring tides, when the Moon, the Earth, and the Sun are aligned, that's either a new moon or a full moon. So the position of the Sun is actually modifying my tides a little bit. Now, the spring tides are probably easier to see. Here's a model for the Earth, and here's the Moon. Since the Moon is much closer, the Moon is going to have a stronger gravitational pull on the Earth, and the Moon's gravity would be pulling the water this way. When the Sun is in the same direction, so let's say I put the Sun here, this would be a new moon. The Sun's gravity is going to pull in the direction that the Moon's gravity is pulling. So the Moon and the Sun are pulling together, and that's going to get you a larger high tide bulge. Now there's a high tide underneath the Moon and a high tide opposite the Moon. So when you're looking at a spring tide, what happens is you get higher high tides and lower low tides. So your high tides are under and opposite, your low tides are at right angles, but for the spring tides, you get a higher high tide and a lower low tide. That's going to give you the maximum range. If I make a model of it over here, okay, the Earth is here. The Moon is to the side. The Moon's gravity is going to create the high tide. Now, if the Sun is in this direction, you see the Earth, the Moon, and the Sun are at right angles. Now the Sun's gravity is pulling where the Moon is creating a low tide. The Moon's always going to have the high tide, but this time the high tide created by the Moon isn't so high. So my high tides are going to be less, and a little more water is going to be available for low tide. So if I look at this, and these tidal bulges are incredibly over-exaggerated. Normally, the difference between high tide and low tide is like 2 or 3 feet. Okay, South Shore of Long Island is like 3 feet. North Shore might be 7 or 8 feet. But this is incredible. This is a 15-meter drop. That's 45-foot drop between high tide and low tide. But here, my neap tides are at first and third quarter. You're going to get a lower high tide and a higher low tide. This is going to be the smaller or the smallest range. Okay, so that's a little explanation for spring tides and neap tides. I'm going to go back to the graph. Okay, the spring tides are where they're farthest apart. Clearly right here, day 17, day 18, right here in the middle, where you're showing a really large variation. I'm going to put a big S along that line for spring. It seems like over here, which is right around when we had the new moon, okay, over here you had a spring tide that was not quite as extreme. But you have spring tides when the high tides and the low tides are hitting maximums. Maximum high, a minimum low. Now, for neap tides, and I'll do this one in pencil, right here, my low tide is higher and my high tide is lower. So over in this range, around day 9, day 10, somewhere in here, this is going to be a neap tide. Likewise, over here, we have a neap tide. All right, so you've got 2 spring tides, but the largest spring tide is occurring right here in the middle, and 2 neap tides. And it's really the phase of the moon and the alignment of the Earth, the moon, and the sun that are causing that. All right, flipping to the back. That one's completely done. But flipping to the back, okay, next we have to calculate the rate of tidal change in the box below. They give me April 18th. I know you know the formula for rate is equal to the change in value over the time. Now, this is asking you from high tide to low tide. We've discussed in class that tides are cyclic, and because the moon moves in the orbit a little bit while the tides are changing, it's not like a whole number of hours. Okay, from high tide to low tide on average is going to take 6 hours and 13 minutes. But to do a good calculation with this, okay, it's really better to do it in, the number of like centimeters per minute. So I take 6 hours, I'm going to multiply that by 60, and that would give me 360 minutes. Okay, I'm going to add my 13 minutes. So from high tide to low tide, you probably don't think of it this way, but should be 373 minutes. Now, looking at the data table, when I look at April 18th, on April 18th, I'm checking out my high tide and my low tide. For April 18th, it's starting at 15.0 and it's ending at negative 0.5 meters. So to find the change, you subtract them. So for this one, if I'm writing this out, the change in value is 15.0 meters minus a minus 0.5 meters, and that would all be over, 6 hours and 13 minutes. I can't divide by 6 hours and 13 minutes. All right, 15 minus a minus 0.5 would give me 15.5 meters, but I want to convert that from meters to centimeters. Honestly, with the metric system, it's really easy to convert. The unit is meters, So all I have to do is shift the decimal 2 places over. There are 100 centimeters in a meter. So if I take 15.5 and I shift the decimal twice, I'm going to fill in the 0. Okay, 15.5 meters is going to equal 1,550 centimeters. And that honestly is going to make my life much easier. So my change in tides was 1,550 centimeters, and that took a total of 373 minutes. All right, now we have a calculator. I just have to do the math. So I get, and you should check your math always, 1550 divided by 373. I'm going to round that to the nearest tenth, and I'm going to get my answer as 4.2 centimeters per minute. All right, so I have to round it. It's 4.15, but I'll just say that this is 4.2 centimeters per minute. Okay, now, general tidal levels associated with each of the following. Well, the new moon was 0% illumination. Okay, I honestly calculated the range on the date that it gave me, and the range for this from the data, that was like day 1, there was a range of 10.5 meters. So during the new moon, you should get a spring tide. Likewise, the full moon's going to be 100%, and the full moon is going to give you a spring tide. What does that mean? That means you get a higher high tide and a lower low tide. That's how the tides vary because of the Earth, the Moon, and the Sun being aligned. Now, when I calculated the range for the full moon, it went all the way up to 13.5 meters. Okay, that was one of the highest ranges. Honestly, you also have apogee and perigee. The moon gets a little closer and farther away, and that's going to change your tidal variation, slightly as well. The first and the last quarter, or the first and the third quarter, as I called it before, okay, those should be Neap Tides. The Neap Tides are going to occur at the quarters, and the quarters are around 50%. So looking back at the data table, when I found the first quarter, I got a range of 8.35 meters. That's a much smaller difference between high tide and low tide. So on a Neap tide, I should have a lower high tide and a higher low tide. All right, 2 more questions to go. Okay. Using your answers to question 3, explain why this occurs. I'm just going to read off what I have written on my other one, because this is getting really long. But when you're looking at this, the spring tides happen when the Earth, the Sun, and the Moon are aligned. So the gravitational pull of the Moon and the Sun create high tide bulges in the same exact locations. Look back at the diagram we drew before. During Neap tides, when the Sun, the Moon, and the Earth are at 90 degrees, the Sun pulls on the low tide, which creates lower high tides and higher low tides. Obviously, you can tell from the graphs that tides are a cyclic relationship. I hope that helped with that activity. I've thrown some extra materials and some extra diagrams in there, but essentially the phase of the moon will change your tides, and specifically when they're telling you the phase of the moon and they're asking you about tides, they're going to look at the tidal range, and they're expecting you to understand spring tides and neap tides. Take care.